Okay, now we are going to learn the displacement diagram for the simple harmonic motion. Simple harmonic motion, you already know that in simple harmonic motion, our follower velocity and acceleration of our follower will change as per position. Okay, so first of all, we are making same as in our last example. You know that first of all we are going to make one rectangle. Okay, so given data is there, rise or lift is a 40 mm, theta 1 rise angle is a 90, dwell is a 30, return angle is a 60, and again dwell is a 180. So first of all we have to make the rectangle size of 18 by lift. Means you know that why 18 by lift, because we have taken 20 degrees equal to 1 centimeter, so our this length of our rectangle will be 18 centimeter. Okay, and this height is lift is given 40, means 4 centimeter. Okay, so 18 by 4 centimeter, because lift is 40 mm, so 4 centimeter is height and 18 centimeter is a length. Okay, so let's start with the first angle, which is given as a 90 degree. So you know that 90 degree, 20 degree is equal to 1 centimeter. So 90 degree is equal to 4.5 centimeter. We have to divide this rectangle in 4 parts. Okay, which 4 parts? As per angle theta 1, 2, 3 and 4. Degree is given, we have to convert that into centimeter. Okay, 90 degree is equal to 4.5 centimeter. Divide by this 90 by this 20 degree. Okay, so 4.5. So let's start. Makes this is the 60. Okay, this is the 90 degree. 90 degree is equal to 4 point. So this distance is 4.5 centimeter. After that you can check here, second angle theta 2 is a dwell, which is 30 degree. 20 degree is equal to 1 centi. Divide 30 degree by 20 degree is equal to 1.5. So this will be 1.5 centimeter. So distance this I have measured from this is equal to 1.5 centimeter. After that, last third angle you can see here, return angle 60 degree. So in our rectangle there will be 3 centimeter will be there. This is the 3 centimeter. Okay, so 3 centimeter. After that, this remaining, if you measure this distance, it will be 9 centimeter, because 180 degree is there, so this distance will be 9 centimeter. Okay, after making this rectangle and divide this rectangle in 4 parts, what you have to do, always remember that whatever the type of displacement diagram, uniform velocity, simple harmonic, uniform acceleration, we will study in next points, but always up to this point procedure will be same. Up to this point procedure is same. 18 degree length, 14 centimeter height, divide by 4 division as per angle, then 6 components, 6 division, again 6 division of rise and 6 division of return. This is the rise and this is the return. So again I am going to divide this in a 6 again. So 4.5 divided by 6. Okay, so 1, and you can divide this 4.5 divided by 6 by some other method also, without using calci. You can use the inclined line method. So now you have divided rise and return in 6 parts. Okay, so check these points. This is the 0, 1, 2, 3, 4, 5 and 6. and this dual we are nothing, we have nothing to do with this, and in this will be always be empty. Okay, so you can check here, this is the point is a 0 1, sorry, this is the 1 2, like this, 3 4 5 and then 6, same as here 0 dash, it will be very near because these points are very near. I am giving directly last point here. Okay, this point which is 6 dash. Okay, this is the 6 dash. Okay, and now for simple harmonic motion you have to make semicircle here. You have to make a semicircle at the end of this rectangle. Center will be this, and make one semicircle here. Okay, I will try again for proper semicircle, and then divide this semicircle in 6 parts. How can you divide this semicircle in 6 parts? You know that this is angle is 180, so you can divide this in a 6 part by this 90 90 and 30 30. Each part will be 30. Okay, and now you have to make parallel lines, means you can give this point as a, okay, these points you have to remember that, and we will make parallel lines with respect to this, like here. And when it like this is a third point and it is reaching to third vertical line, it will give us the points for the diagram. Okay, sorry, so you can check here, these are the points which are important because we are going to make the curvature here dual, and same point we will get from the parallel point with respect to this, there will be here some point. Okay, and that's how you will get this diagram, simple harmonic motion. Check here. Okay, you have to make these parallel lines here, like this point is, you can see you will draw this line, and this 0 1 2, and you can see there it will intersecting these 2 points, and you will get this diagram which is known as a displacement diagram as per simple harmonic motion. Okay, now we are going to for the next diagram, which is a uniform acceleration and retardation diagram, which is very similar to uniform velocity, but it is very lengthy. So first of all, you have to make same as a one rectangle, okay, whose length will be 18 centimeter, height will be 4 centimeter, because as per data. Now you will divide this. Now you are going to divide this rectangle into 4 parts. Depend on this angle. 100 means 5 centimeter. Okay, 5 centimeter. After that 18 degree means 4 centimeter. 4 centimeter. After that 90 is equal to 4.5. Sorry. વાન આ ગયું, આ ફાઇનલ થયું જ નહીં એમ ને. So same as a simple harmonic motion, you are going to make a rectangle whose length will be 18 centimeter and height will be 4 centimeter because the lift is given. After that you are going to make 4 parts as per this given data. So first is a 100 means you are going to make this 5 centimeter, 5 centimeter. After that second part, okay, second 18 centimeter means 18 degree, 20 degrees equal to 1 centimeter, 80 degrees equal to 4 centimeter. So you are going to this 4 centimeter here, so it will be 4 centimeter. After that 90 degree is equal to 4.5 centimeter, and you are going to this 4.5 and 4.5. So that's how you will complete this 4 partition of this rectangle. Okay, after that, as you know, we are going to part rise and return in 6 divisions. So let's make 6 parts of so up to this point you have to make this. Up to this point procedure will be same. It is totally depend upon which type of diagram is asked. So always we have to make this diagram first, and out of 7 there will be minimum 3 marks can be given by this if you make proper displacement diagram. Okay, so 6 part of rise and 6 part of return. After that, for uniform acceleration diagram, you have to make, you will give the notation here, all the notation like here, like 0, here 1, 2, 3, 4, 5, 6, 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash and 6 dash. After that you will divide division of this center line. Okay, division of this line means 40 semi is there, 40 divided by 6, whatever you get the answer, divide this line in 6 parts, and like center. So I am dividing this center line in a 6 parts by measuring by scale. Okay, so I have divided 6 parts of this center line, rise and return both. After that I am going to make first of all one center line here from up to end, which is must pass through the center point here. Okay, you can check it is passed through the center point, and same I will make this center line here, which is okay. But after that what I am going to do, this 2 point will connect to this end point, and this 2 point will connect to the starting point. Same I am repeating here, these 2 points will be connected to start, and this 2 will connected to here. Okay, but after that through which point we are going to draw this uniform acceleration diagram. So check this, these are the points through which we are going to draw the diagram. How we can get that? So we can give the number here. This is the 0, this is 1, 2, this is the 3, this is the 4, 5, and topmost is a 6. So you can see that 5 number line inclined line and 5 number vertical line intersecting here, 4 number inclined, 4 number vertical intersecting here, 3 number inclined and 3 number vertical and these are the points through which we are going to make the uniform acceleration curve. It is dual, and after that you can check this is the points you will get here. Okay, let's check by given figure in book. So this is the uniform acceleration diagram. Check here. After dividing this center line, you can check this line which are intersecting the vertical line, you will get these points, and through this point you will get the uniform acceleration diagram, and same as a retardation. Okay, now last and a very important diagram as displacement diagram for the cycloidal motion. Okay, it is very tricky and very rare, you can see in a book, because it is very it is asked a very less time. Okay, so how you will make this? So check this. First of all, you are going to make the rectangle, as you know that you will make the rectangle 18 semi by height, and after that you will divide in 4 parts, 1, 2, 3 and 4, depend upon these angles. 120 means this distance will be 6 centimeter. Okay, this is the 6 centimeter, and after that 60 means this will be 3 centimeter, 60 3 centimeter, and 120 means 6. Okay, so as per given data you will divide this, but after that what you are going to do, 6 parts of rise, okay, here, and 6 part of return. And after that, this is the similar procedure as the last displacement diagrams, but for the rise you are going to this different. In this case, what you are going to do, you are making one circle here, and radius of this circle is equal to s by 2 pi. Okay, you will make at a corner, you know that you are making this rectangle total, and here at a center you will make some circle here, and radius of this circle is equal to lip divided by 2 pi. Okay, you can check here, and after that divide this circle in a 6 parts. Which 6 part? First is the origin point, and you can check I am making these lines. So 1, 2, because 360 is total, 360 by 6, all angle, this angle will be 60. Okay, this angle all will be 60. Divide this circle in a 6 parts, you can get only these points here which are apart 60 degree from each other, and then connect this 4 and 5, 3 and 6, 2 and 1, and make sure there is a vertical line is there. Okay, vertical line will be there, and you will get these points, which center of 4 5, center of 4 5, center of 3 6, and center of 1 2. We are going to draw these lines here from center of 3 6, we are going to up to end point, same as from center 4 5 parallel. This line will be always parallel to this center line, and same as from center of 1 2. So that's how you will make these center lines here, and after that you will draw this diagram which is known as a cycloidal motion. Okay, thank you.